Hello and welcome to this DevTalk on integrating Zebra VisibilityIQ APIs into your systems. We are going to demonstrate this integration using a Node.js service. Here is the agenda. We are going to do a quick overview of the VIQ. VIQ is short for VisibilityIQ. The VIQ APIs. Then we will look at backend integration of VIQ APIs. And then we will talk about access control or security for the APIs. And then we will look at using the APIs, some request and response structures of the API. And then finally, we will be doing the demo, in which we will create a snapshot of the repair lifecycle. VIQ APIs provide analytics and data related to device support, such as the support cases or repair, operation, and health. There was an earlier session today. You can take a look at that, which gets into the detail of the APIs, which we are not going to get into, like what APIs are available. But here we will deep dive and look at a particular API and use that for integration. There's also documentation available at the developer portal. Here's the link, and it looks like this, where you can see an overview of the APIs. There are some videos about how to use the APIs, and then there are the specifications. So for example, we will be looking at repair lifecycle, and we will be using these endpoints. So all these specifications are available on the developer portal. These specs can also be used to generate starter client code if you're just getting started. Next, let's take a look at backend integration examples and use cases. So we need backend integration if we have a situation such as business process automation, or we want to synchronize data where we are keeping a copy of the data, or we may want to enrich data where we have some data and then we want to use data coming in from VisibilityIQ, and then we could combine that. In this case, the client is the system because it's not necessarily an end user who has access to VIQ. Therefore, typically you would use a service account ID, which can pull data using the VIQ APIs. However, that data can then be presented to other users, for example, in your intranet, or maybe even for your own customers. For securing these APIs, we will be using the OAuth to device authorization flow. We are going to get into the details of that a little bit later. Here are some more specific examples of how these APIs could be used. For example, if there are some critical battery events, you could use that information to send an MDM notification to the device. MDM is a mobile device management service provider. Typically, that's a provider you use to manage your devices, and they provide you APIs to talk to the device. So you could send a notification to the device indicating that the battery needs to be replaced or charged. You could also monitor the operating system and business application versions for reported issues. So the operating system version and business application version, that information could be retrieved from VIQ APIs. But you could also separately be looking at reported issues for various versions, and then you could combine that information together to decide on a course of action. Another use case is where a license fee is paid usually for an MDM system when a device is associated with that. But if you're going to send a device to a Zebra repair facility, then that device is not really using that MDM system. So if you could take it out from that system, then you're not paying the license fee for that duration. So this is another use case where a VIQ API integration could be useful. You could also monitor battery health across the fleet of devices. This could be useful, for example, when you're preparing for, let's say, holiday season, before Christmas. So just planning for that, you can avoid disruptions during peak season. If you knew that you need to order and replace some batteries across your fleet or in a particular warehouse, that information can be available using the IQ APIs. You could also monitor application freezes. So if some applications are freezing a lot, maybe after a particular upgrade or for a particular version, then using that information, you can enable diagnostic information uh, using the app called RX Logger. And another simple use case I kind of mentioned earlier is you may have an asset management system where you have information about these devices, and you can enrich that using data coming from VIQ APIs for these devices. Okay, next, let's take a look at the access control for the API. This is the security aspect. So VisibilityIQ APIs use the OAuth to device authorization flow. This is similar to an experience you might have had if you've done anything like or used anything like a smart TV. For example, if you have a smart TV or if you have Roku and you want to log into the YouTube application there, you're telling YouTube that this TV is going to act on my behalf and would want to retrieve information for my account. So you have to authorize it once. That's typically you see a code being given, and then you log into some URL, enter that code, maybe log into YouTube and say, yes, authorize this device. It is the exact same flow. So in this case, the device is the backend system or application that is going to integrate with VIQ API. So first step, it gets a device code using client credentials. Client credentials are a client ID and a client secret combination that uh, need to be set up in our API gateway. This is the initial step for anyone to be able to call the APIs. So once we get the device code, we go to our identity provider, which is Ping, and you authorize that device code. You have to log into Ping using a user ID that has been set up, or that's very easy to register. If it's not, that's the service account ID. And with this process, we are associating the service account ID with that device code. And implicitly, any of the tokens that will be generated later with that device code will also embed that user ID. That's how we know that this token is for this particular service account and what data it has access to within VIQ. And once that pair of access and refresh token is obtained, we can hold on to the refresh token, and whenever the access token expires, we can use the refresh token to get another new pair, and then again hold on to that refresh token. So as long as we hold on to the last refresh token, we can get another pair. And we have to use the access token in each of the API calls. So we will look at a little bit more detail in the next few slides. This is the same information in a little bit more detail. You use the client secret once to obtain a device code. Client secret is like a password. We don't want to send it over the wire frequently. So you do it once to get a device code. Then we authorize the device code, and that's where you link the service account user ID with the device code. Once that is done, we use the device code to obtain the pair of refresh and access token. The access token lasts for 1 hour, after which it will say it's expired, so you will get unauthorized status 401. The refresh token is single use, so each time you use it, you get a new pair of refresh and access tokens, so you have to hold on to the new refresh token. We want to persist the refresh token because if, you know, for whatever reason you don't use it for a while and you come back, you still want to have that refresh token. If it's going to be persisted, we recommend that it be encrypted for security purposes. Ideally, in a production system, you would use something like a vault or Google Secret Manager to store this. But if you keep it in a database or another store, you should encrypt yourself. And then cache the access token, because access token we keep using repeatedly until it expires. So when the access token expires, we use the last refresh token, like I said, to get a new pair, persist the new refresh token, and cache the access token again. A couple of observations. Client secret is sent on the wire only once per client or device, unless we need to reauthorize the client. And that can happen if, for any reason, the refresh token is lost, wherever you're storing it. If that storage gets corrupted, in that case, that intervention will be needed. And then refresh token only needs to be sent on the wire once about an hour, because the access token can last for an hour. Next, let's take a look at how to use the APIs, given that we are able to obtain a token. The API key, or the client ID, that is required on every call. An access token, as explained earlier, is also required in every call. Each API has the same pagination parameters, which are provided in the query string. These are the limit and offset. Offset says where in the total results that we're starting, and limit is how many results are in one page. All other parameters are in headers, so that keeps the sensitive information in headers, which on an HTTPS connection will go encrypted and won't be logged unless someone is explicitly logging them. And the error and success responses have a standard structure, so that makes it easy to use these APIs. Here is an example of a successful response. So let's take a look at that. Each response always includes the HTTPS status, just with the name status. So for a successful response, it will show 200. There is a section on metadata of the results. So there's always a total, which tells how many total results match the query. However, not all the total results may be returned in that response. So for example, if you matched 10,000 responses, 10,000 records, but the page size is 250, then at one time you are getting 250. So the total tells you the total match. Offset tells you where the results that are in this response starting in that total. And then limit says how many records are being returned at most in a particular response. And then the ID is a unique request ID. This can be used for troubleshooting. So if you have a problem and you open a ticket, you can provide this request ID, which helps us troubleshoot and find relevant information with that request, for that request. There is also a links section. This is useful if you are implementing maybe some kind of UI or walking through the pages. The self link is the link to the current request. It's kind of cut off, but there, at the end there are the limit and offset parameters. The first link points to the first page, last points to the last page, and next takes you to the next page. And after that, there is the section which is the data array, and each element of this data array is one record in the response. And we'll take a look at this in the demo. Similarly, there is a standard structure that you can expect in the error response. There is the unique request ID. There is the HTTP status, which is 400 in this case, which says a bad request. There is an error code. This is an internal error code, which gives a more specific detail about the problem. The title is the general category of this error, in this case, it is saying the API request does not follow the spec. The detail tells you more specifically what happened. And here, in this particular case, it is talking about the range, the difference between the start and the end date time parameters. Again, the detail is cut off. There's more to this message. And then there is the source section, which talks about what is causing the problem, which parameter, and then where can you find it. So start date time, and you can find it in the header section. Okay, with that background and overview, we can talk a little bit about the demo, and then we will have the demo. This is a simple snapshot. It's just a page showing the total number of devices in repair lifecycle states. What that means is on a given day, how many devices are in these different states. So for example, 5 open repairs. That means that there are 5 repairs that have been opened, but those devices have not reached the repair depot yet. 4 of these are expected. That means that the devices have been sent, but they have not reached the repair depot. 8 of these are in repair, meaning they have reached the repair depot and they're being worked on. And then 1 has been repaired and it's waiting to be shipped. 1 of them has been shipped. And some customers have a spare pool where they can have some reserved devices. In this particular case, there are 0 devices in the spare pool. And this data is for a demo company that we will be using for the demo. And the same information is shown in form of a bar chart at the bottom, where on the left you can see the repair states, and on the right, on the x-axis, you can see the device count. Here is a simple architecture diagram for the service that we will be showing. There is a Node.js service. We make requests using the browser, and it reaches out to the VisibilityIQ endpoints. In this case, we have shown the repair endpoints. It makes a call to those 6 endpoints and gets the totals. And then it combines them with the view, which is a template for the page, and it just fills in that data that it collected from those 6 calls. And then it returns that to the browser for rendering. Also shown is the token storage and the identity provider endpoints for generating the device code and obtaining a token. But that interaction is not shown in this particular flow, which assumes that we have a valid token and then we're using it for making the calls. Okay, so let's switch over to the demo. This service is running locally and it has a few endpoints. So for example, at the root, I have shown here just some information about the ping identity provider. It talks about what capabilities that identity provider has, what endpoints it supports, what algorithms it supports, and this is the device authorization for the device code. So this is just some general information about the identity provider. I have another endpoint here, and this is just showing data that is coming back from when the service calls the endpoint, it is just rendering the response here so we can view it easily. If I need a new device code, I can call this. And as you see, it has extracted from the response the URL. And I'm using a non-production system. That's why it is showing the test PI for test ping. And that's the device code. So we can authorize it. And as you can see, I'm logging into ping now. And that's my ID. So I'm using my ID. And that's the way it knows that this ID is being associated with that device code. And once I confirm, and then finally, I am approving that this ID be associated with that particular code. And at this point, that has been authorized. And then I can retrieve a token set. This information that whatever I'm doing is being held by the service in this demo, so I don't have to send it back again. And I'm obtaining a token, a pair of tokens. So this is the access token, and that's the refresh token. So the service, while it is giving it back to me, is also encrypting and storing it locally. But in a production system, we would store it in an encrypted store, such as an encrypted KVM or Google Secret Manager or Vault. Or if you were going to store it in a database, then you would like to encrypt it yourself. And then we'll make one of the API calls to see the response. In this case, you can see that there's a total of 5 matches. Offset to 0, meaning we are on the first page. Limit is 1, meaning I said I only want 1 record in a page, so I got 1 record here, even though I have 5. And this is my request ID. And this is how one of the records looks like. There is a date on the record, model of the device, when was the repair opened. This is all demo data, so it's all made up. But these are the fields that you will see. For example, here it's saying there is a problem with the display. That's what that needs repair. And finally, we can take a look at the repair lifecycle snapshot, which is similar to the screen I showed earlier. Now here I can pull it for a different date, but this is by default, it's using 5/17. So maybe I can go look for an older date. So for example, 12th March here. And so this is the data it got for 12th March. So here there are more shipped on this date. So there's 12 devices. Again, this is a demo company, demo data, but for a real company, you will see probably much larger. These could be in tens or hundreds, depending on the size of the customer and the number of devices they have. And I can quickly show how this is implemented in Node.js service. So there's the index.js. This is just the routers or the controllers. And then this is the module where all the logic is present for calling the VIQ APIs. So we're using an OpenID client. It just makes it very easy to make the OAuth calls. We're using the GOT package. You can use another HTTP client or a different package for making the API calls. The crypto package we're using for encrypting the refresh token before storing it. Node persist, this is used for storing the refresh token locally. In a production system, like I said earlier, you want to use a better storage, an encrypted storage or an encrypted value in the database. And EJS is just the template rendering for rendering the page by merging the data in it. That's just initializing the storage. And as you can see here, these values are kind of configured or hard coded here. The date part is modifiable, but all of it, for depending on an actual use case, you can make it configurable. For our case, we've just put it in one place, the customer information, the credentials, such as the client ID, client secret, or the key for encryption. None of that is in the code, that is in the environment. So it is using that from the environment. These are the variables where we hold these, the OAuth client information, device code, token set. This is the call. As you can see, this issuer is this coming from OAuth, the OpenID client package. And just by giving an API URL, it can obtain the information that we saw about the ping ID identity provider. And this is where it is initializing it, and it is putting the client ID and secret in it so that we don't have to repeatedly provide that. And these are various functions being exported from here, getting information about the OAuth issuer, getting a device code, and this is the JSON object from which we get that URL for authorizing the device code. And this is where we obtain a new token pair. So if we don't have any token pair, like this is the first time, then it is trying to look for, did we have a previously stored refresh token? It's trying to extract it from the storage and decrypt it. And even if we don't have that either, because this is the first time ever we are running it, then it is trying to obtain it using the device code. That means that we should have authorized the device code before calling this. Otherwise, we may also have a case where we're trying to force a new token. Then in that case, even if we had from before, we can force a new token or new pair of tokens. And once we get a new token, then we save the refresh token by encrypting it. Similarly, so this one is the getting a repair response, and this one makes a call to one endpoint, and the structure is very similar. So if you see, other than this repair type, which was open, expected, and repair, those different states. So that's the only thing that is changing. So this is a shared function that has a parameter, what kind of repair we are trying to pull. It calls that and just returns the body. And then here we are looking for if the status is 401, which is unauthorized, um, then we have to get a new token by forcing a new token here by passing true. Otherwise, this is the top level function which goes through these 6 states: open, expected, and repair, and then calls that previous method get repairs repeatedly. So it's making the 6 calls, and it keeps adding the result to the uh, to the to the object holding that repair type. And then it builds that object, and then it renders here right here. So that customer information, date information, and this total is that object containing the totals for these 6 calls. And those are being rendered on that view. Which we see here. So this 5, 4, 8, 1, 12, and 0. These are the totals retrieved from each of the 6 API calls. So this is the complete demo and the example. And I would like to open any questions at this time.